Right, we've got a brilliant talk coming up next. I'm really looking forward to it. I hope you all are too. It's called The Singularity, Classical Ballet, Computing and Digital Ethics. So without further ado, I'm going to hand over to Genevieve and Alex. Give them a nice round of applause, everybody.
Hi. So it is a little bit weird to talk about classical ballet and its computing education, and the digital ethics includes bio-digital ethics. But before we get there, I'll kind of explain why I'm doing this, because it makes a little bit more sense for you. So this is me and all of the things that I do in an infographic by a really wonderful artist called Annalise Lim. So apart from running Ready Salted Code, which is a not-for-profit creative computer education CIC, I also am a lecturer at Roehampton in computing education. So I kind of come from the classroom teaching GCSE and A-level computing, computer science, software development and games design, into now teaching new teachers and developing the creative computing. So when I was teaching, there was only me as the female in the classroom. So I wanted to find a way of getting more girls interested in computer science, as well as being a little bit more creative and not just doing, Python and the magic 8-ball that we all have to teach these days. So I went to dancing school when I was very little. And that's my passion, along with the Dragon 32 and Ice Castles. That was my favorite game. But unfortunately, I had a condition called spondylolisthesis. So I have multiple spinal fusions. I ended up leaving my walking stick on the drive, so I've had to resort to using a golf umbrella this weekend. So yeah, so that's where my kind of passion for classical ballet comes from. And I now use classical ballet as a medium for teaching computer science theory. I've produced 3 ballets along with Alex and also our choreographer Camilla. And that is a fluoroscope of my spinal implant. And I use classical ballet because how it aligns with computer science theory. So if you don't know anything about classical ballet, it is very, very strict and rigid, like a programming language. So for example, I'll sort of half demo here. So you have positions of your feet, which also correspond to positions of your arms. And there's only certain ways that you can combine them to be correct motifs. So if you think about how you might position your foot, and there's certain steps that you're allowed to do, are very rigid and very strict, the same way as you might get with Python or JavaScript or whatever language that you want to use. I'm very language agnostic. And that is why we use it as a way to sort of show that the language can be algorithmically created for the ballet. Our ballets use secondary school students that are not computer science students, nor are they professional dancers. I don't dance, I just choreograph some of it and enjoy it because it's kind of cool. So it was a really, really good way to create different elements that you could use in for teaching computer science theory. Not only can you manifest or use classical ballet as the narration and the data as the storytelling, we can also create workshops and resources for teachers for all the wearables that we do. We did projection mapping, and Alex also built our Connect server. So if you ever want to just grab some JSON data from a Connect, we've got a brilliant one that just literally, you just type in how many keyframes you want and it'll just schlep up the data. So yeah, I need easy stuff. I'm a kind of a mediocre programmer. So the very first ballet we did, we coincided with the introduction of the new computing curriculum, and it included 5 different elements. So Boolean and binary, computational thinking, debugging, big data, and algorithms. And we used projection mapping, live weather data, and also lots of wearables. So that was a way that we could teach students Arduinos. And it's a really, really good way, electronics are a really good way to introduce coding as well. So there's a couple of, we used torches, and this is a picture of the Connect, just when we were doing binary tree structures, just to show you what it looks like. It doesn't have to look like Stickman, it can be really beautiful. And what's interesting for me is I know that that's Kate. I can tell how she dances. So that was quite interesting from our perspective. So we did a lot of different things. So the very top one with the circles is 100 years of rain data. Then one next to it is signal processing, where the dancers are using different motifs to represent the signal processing algorithms. The one at the bottom with the connect stick figure is for debugging, so that's where we have all this trace and errors in it. And the one at the very bottom represents networks and viruses. We use a lot of wearable technology in the ballets, and these initially were, electronics, wearables, and point shoes are not friends. I'm just saying, they do not like each other at all. So every single performance, they always break. So the perfect rehearsals, absolutely no problem. One little test up, go live, all the connections snap. And it's literally, is it every performance? Yeah, every. Yeah. So we're kind of needing to find a new way. So this is using the Adafruit gemma, and it's, oh, not the gemma, the flora, neopixels. And the little inside bit that looks like a piece of black plastic is Velostat. So it's pressure sensitive plastic. Looks a bit like a bin bag, but it's pressure sensitive plastic. And that's how we use that as a trigger in the point shoes, so we could minimize risk to the actual dancers. We did, our latest ballet is called Painboat. That was released last October, and that was about chronic pain and biomedical engineering. So the dancers represented pain signals, and we had some dancers representing the biomedical engineering technology, my implant, and then we went through and did what the pain pathway system looks like and how we can modify it, and using art features to create imagery so audience could understand the hidden nature of chronic pain. We also created a VR experience and then turned that into workshops. So this is the technologies that we use. And so the Daydream Alex built using lots of different stuff. And the CoSpaces is a education platform for building VR experiences using CoSpaces blocks, Blockly, and JavaScript. And it's really, really easy to use. I just had 60 kids build it up in Sheffield, having fun. And it just works with a Google Cardboard. But it's a really good way to introduce coding for students before you might want to move on to build VR experiences in Blender or Unity. So it's nice to do lots of different things. So our fourth ballet that we're producing is called the Singularity. And this is about, so from a computer science perspective, we want to talk about latency and communication and augmentation of the human body. So that's why we're boldly going into space. So how can we communicate when we travel into space or go to colonize? And what will we need to do in order to facilitate the human body to do that? Do we need to augment it? And then this is where the challenge comes in. If we are going to do that, what are the ethical considerations that we need to look at? So should we augment people or should we just send robots? What are the ethical decisions of who owns that data if you have a biomedical implant? So that's one of the things that we want to think about with the students when we're teaching the digital ethics is what data are you sharing when you have your fingerprint to get your lunch or book your library book? Which is fine, it's perfectly acceptable, but they need to understand what's going on. So the reason why we're going to be using the emotive headset, which Alex has got on, and that captures your brainwave data. Alex is going to model the emotive headset, everybody. Little catwalk for you, everyone. And so this has a 5-point connection, and the emotive do another one called the Epoch, which has 10 points. It's obviously nowhere near as good as what our neuroscientists would use, but obviously we need one that you can use when you're dancing. It's very noisy, the signal. It's not brilliant, but you know, it's better than nothing. This is just an animation of kind of what brainwave signals might look like in a pretty way. So when you get the emotive headset, it gives you an app like this that you can use, or a couple of pieces of different software to download, either Mac or Windows, and you can get the raw data out. Unfortunately, I don't have that one because that's too expensive. As everything's too expensive. But they're brilliant. They're really helpful as well, the staff. And then I've got a little video that I recorded of my brain yesterday panicking about this workshop. This talk, sorry. So you can see it gives you like a little kind of animation of how your brain might light up. It's obviously not accurate. It's a representation of the signals coming from the brain. And we want to use this particular data to create biofeedback. So this data that's coming out, so it's in a format called OSC. You can use that with many different things, so including things like Sonic Pi, so you could control the music using the brainwave data. I don't really know how well that would sound, but it might be okay. So that's one of the things that we're looking at. We want to create our own new music using all of our bio data for the classical ballet, so that we can also minimize the sort of copyright of the music that we're using. We also want to show how students can code their own music and create their own music, but all with the understanding of this is someone's hidden brain data. What does that mean to show this data to other people? What are the ethical considerations when you're working with that? So I'm going to hand you over to Alex, because Alex built the Scratch plugin that we're going to be using in the workshop later, and how you can use the OSC data from their Motive headset to control Scratch. So I'll hand you over. Thank you.
Hello. So yeah, I'm Alex. I've been Genevieve's technical provider, so whatever it's called, for ages. And I'm a software developer by trade, so for me this is a really cool opportunity to do stuff that is not like regular programming. Programming for performance is nothing like day job programming. With a day job, you're going to have to support it in 6 months' time. You're hopefully going to be supporting it in 2 years' time and still have a job. Whereas with a performance, it's like develop, gone. So there's a lot of hacking. There's a lot of just do it with whatever weird technology you can find. Fortunately for this project, we saw it had an OSC interface to the brainwaves, and I was like, I've done OSC before. OSC is really simple. OSC is, it was invented for control. It's open sound control. If you want to Google it, it was invented for replacing MIDI, which was rubbish. Actually, it's great, but it wasn't detailed enough. So it's basically a way of passing strings and numbers fast across a network. And in this case, the strings and numbers are bits of brainwave information. So you'll get, there's lots of facial recognition stuff as well. I don't know quite how it knows whether I'm smiling or not, but it does. So that's kind of cool. And winking and blinking. But you can also send mental commands, so you can train it to pull and push and things. So we're picking those things up and sending them to a little server that's part of our project. And then, next slide. Thank you. Yeah, it goes into Scratch. And you can have this data, and you can use it to move things around with your mind in Scratch. It gives you control over, well, typically that cat. Is it called Scratch? It's called Scratch, isn't it? Yeah. And yeah, where was I going with that? So it's about making it simple. It's about giving you control over it. Scratch has had 3 iterations. It's currently in beta for its 3rd, which is a big relief to me because I didn't want to ever program in Flash ever again. So it's now available in HTML, and that's much nicer. So we downloaded that, forked it, and just added in some bits to allow us to connect our module to the rest of Scratch. And it's just very, the OSC comes in, it's just numbers and strings, and our little server just pokes it into Scratch, and then it's just like writing a web page. It's just a bit of JavaScript. It connects to an API and says, what's this number? And it says 5. So really, really simple, but it's very, very nice that Scratch has enabled this and made it simple, and it's just like a little green bar and a little orange bar. This is a thing for moving the cat whenever you will it to go. I think left. Yes, it makes it walk. But just an example, you could do anything. You can visualize your thoughts. Obviously, as Genevieve was saying, we use the cheap version of the license, so we don't get all the really detailed data of this is going boom and this is going boom. We've kind of got, what you saw in the previous slide. But it's still a lot to show, how you can use your brain. and how you can use that data yourself as somebody who's maybe not particularly familiar with computers.
Yeah, so Scratch 3 is in beta, so some of it's not fully working. So when you come to the workshop, do be prepared for it to be a little bit broken. I'm just preparing myself, basically, yeah. And then the other thing that we're going to have a try with is Sonic Pi. So if any of you are interested in coding music, that's a really, really good platform to do that. So, and this is only just started because Scratch 3 was only released in August. So it's only been released to other developers, and it's still in beta, and there's still a few things so you can't save any of these files that you create because they are just live running on a beta server, just so you know that when you go online. But it's much better now that it's HTML5 and not Flash anymore. Obviously, we're sharing the Scratch one here because we want to introduce digital ethics to students. But for us, when we're using it in the ballet, we'll probably be using the OSC data to control the stage lights, but using an aggregate score of the wearers so that nobody's data is shown or nobody's data is available to other people. So we won't record anyone's data at all, only my own and probably Alex's. In order to use the headset as well, you officially have to be 16. But obviously, if there's some parents in the workshop and they sign a waiver, they can put it on, but we won't record anything, but it's just, you might want to try it. It's incredibly uncomfortable. It's really tight on your head and you get divots in your head, but that's quite useful when you're dancing. Because obviously you move around a lot. Even in ballet, even if you're not jumping around, there's still quite a lot of head movements and stuff. And it does stay on if you do like a pirouette or a spin, if you don't know what one of those are. And that was really important for us to find a way that we could record the dancers' data while they're doing it, and then use them for the visualizations, the wearables, and any of the projections that we might do. We've only just started on this. We haven't quite kind of formulated how the ballet will finally be, but it's most likely be sometime next October to December when we do the live performance. So I just have some links that you might be interested in. We have all of our resources in GitHub. So for all of our ballets, all of the wearable code, the Connect server code, the whatever code we've used, they're all in GitHub.
Do not judge my programming.
Do not judge mine either. Oh my God. And also it's so messy. Oh. Also the ballets are on data-driven dance. So the 3 that are recorded, I say 3, the last one isn't quite up yet. And if you are interested in the emotive headset, there is other headsets that you can use. It was just this one was had enough points on it to get enough data, whereas a lot of the others only have 1 or 2 that are within my price budget. So it's $300 for one. And when you're doing a classical ballet for one performance, so what Alex was saying from start to development to do on a single performance is round about £20,000. Because if you've got 8 dancers, 8 sets of point shoes, 8 sets of costumes, 1,000,000,001 neopixels, because obviously you're going to have loads of neopixels. I'm surprised I didn't have any on me. I'm normally just walking around in hundreds of lights. But yeah, so and obviously the development cost of all the software that we use, the hiring and stuff. So it's important that, so that's why it takes a lot of time, because obviously you have to get the funding for that. But yeah, so ballet is quite an expensive thing to do if you're interested in that. But mainly to do the costumes and things like that. That's where it comes from. But yeah, so I hope you found the talk really interesting. And if you were all good, hope you enjoyed it. Yeah, if you want to.
So I was going to say, we've got 10 minutes if any of you want to ask questions. But before we do that, you mentioned that you're going to be doing a workshop later.
Yeah.
Do you know when and where that is?
Yeah, so it's 6:30 in workshop 2.
There you go. So, do we have any questions from the floor?
Hopefully not.
No. Oh, one there. Oh, and one there. Well, I'll come back to you. Can you stick your hand up again? There you go.
Hi there. Can you support multiplayer type experiences with this sort of headset as well, or is it solely one headset per computer?
Yeah, go ahead.
So the OSC protocol is completely network agnostic. So even if you only have one plugged into one computer, you could certainly then take that data and glue loads of it together.
Any more for any more?
No.
Oh, one here.
Could you demo the thing with Scratch?
Yeah, that's what we're doing in the workshop later on.
Okay.
Yep. We just can't do it now because it's the different laptop.
What do you think is the most interesting thing you found from using the headsets on the dancers?
So we haven't used it on the dancers yet because I only just got it. But I use it on myself, and I have ballet lessons. And I think the thing I found was actually the other dancers. So I go to a dance class which has everyone's over 60 doing it, and so the other ladies were watching my brainwave data, and they found it absolutely fascinating how that you can see what you're, because we were learning new stuff, so we could see what you were doing and how it kind of affected the visualization of what's going on in your head. Just the fact that you could see it, and that was one of the things that we were talking about, the fact that you can see this. There is an ethical issue of it, because like you can imagine if you in the future, if they use your brain waves to decide what job you're going to have or whatever, that kind of thing. So yeah.
One over there. Oh, sorry. Yeah, that's right. Where are my manners?
Why did you choose to do the brainwave stuff thingy, whatever?
Why did I choose brainwaves? Basically, a little bit came from the previous ballet where we had chronic pain and the hidden nature of chronic pain. The fact that you don't see that I'm in chronic pain. So we're trying to expose it. And then, so we're trying to find different ways that you could expose other data that might help you understand ethical decisions and things like that. Thank you.
Thank you.
There was one over there. Yes.
So are you aiming to get data from the way their dancers dance in any case, or to give them something they can consciously affect and control?
That's one of the where we work with our dancers as well, so they're part of the whole development process. So what we kind of want to look at when you're learning the classical ballet, like what do the brain waves look like, and then kind of once you know it, is there a difference, and can we affect the wearables or the lights or the projections, basically. So they may want to be interested in how it does the element that you were talking about, the kind of learning feedback system. We wanted to look at it as a sort of a biofeedback, maybe, but we haven't quite got there yet. So we're still deciding, but that's a brilliant idea. Thank you.
Thanks.
Oh, one over there.
I know you've not had it long, but how accurate do you find the brainwave?
I'm not a neuroscientist, but I'm assuming they're not that accurate. Is there any neuroscientists in the room? There is one. Ben could probably help us. They're not.
I've never had the pleasure of actually playing with one.
Oh, you can play with it later.
Excellent. I'll see you for that later.
Yep. So you can get the raw EEG data off it, but it does require you paying for another piece of software. And obviously one of the things that we try and do is do free and open source stuff. So this is kind of limiting when we want to try and put this out into a sort of classroom learning situation. But what I'll do is I'll maybe do a comparison with a proper EEG headset and treat it, like get some and do a post on it so we can see the comparison between the data sets. There is another headset which is more accurate, but again, that's double the price or triple the price. So yeah.
Oh, one over here, and I think we'll make that the last
Yeah.
one.
Hi there. That's really good talk. Thank you very much. So my question is, have you considered, so putting possibly the ethical part aside or coming up with a way to aggregate it so you can't look at an individual, putting the headset on audience members or the people who are watching or experiencing the ballet? Because I think that would be a very interesting thing to add into the performance.
Yeah, that's what we're going to do, but we won't be where we're talking about the recording. That's only on us externally, and we will share. The only data that we'll share publicly is mine, because that's fine. But we're looking to use the audience's aggregated feedback to control some element of the live performance. Obviously, that's just going to go terribly wrong, isn't it? But it'll be fabulous. But yeah, no, brilliant. Yeah, brilliant idea. Thank you.
Thank you.
Okay, thank you. One last round of applause for Genevieve and Alex. And let's get another plug in for their workshop. 6:30 in workshop 2, is that right? Yes, go to it.